Okay, guys, today we shall talk about electromagnetic waves. In the last class, we have talked about electromagnetic waves. That is about current displacement, history of electromagnetic waves, and also Maxwell's equations, etc. Today, also, we are going to talk about electromagnetic waves. We will continue this unit, electromagnetic waves. We na pohin kan chun zomanga electromagnetic waves ka. Electromagnetic waves 2 ka tia electromagnetic waves 2 le one hi om than chong lo ma ro chu I ka then nan karon da mai ni. Today we shall learn about what is electromagnetic waves, or we can say definition of electromagnetic waves, production of electromagnetic waves, and propagations of electromagnetic waves, and also about I shall talk about permittivity and permeability, and in the last properties of electromagnetic waves. Okay, so we are going to learn about these 5 things today. So what are electromagnetic waves? In the last class I have talked about electromagnetic waves, and also I give some examples, isn't it? Example claim take BPA hey TV kan pek chua te tin mobile phone kan biak na wave te heng kan hu thailo hi electromagnetic waves ani kan ti to a ichon bo voina thian bo ro ka chu chip chir zokin bo engtin nge in producer bo ro ka engtin nge kal enge properties ti kan zir donai. So first of all, what are electromagnetic waves? The transverse time varying and electric and magnetic fields propagating in space in a direction perpendicular to the directions of both the electric and magnetic fields are said to constitute electromagnetic waves. Electromagnetic waves are nothing but it is a combination of the changing electric and magnetic fields. Okay, electric field chereng le magnetic field chereng in an siaman ya arwal chin boroka an kala chon electric field and magnetic field po kha perpendicular in an kala ni mo chu boroka an kala alim nen kan lo endona ni chu ni transverse time varying ti chu transverse ti chu in perpendicular ti na ni maya boroka electric field and magnetic field kha perpendicular in an phone chuak ta a chu ni tani ingtin nge electromagnetic waves kha allow in siam kan ti chon how do electromagnetic waves produce. Number 1 is the conduction current produce magnetic field due to charges in motion. Hey chu kan thretonga conduction hey electric current pang wire a local chuan the magnetic field in siam ti kan thria. Whereas the displacement current produces magnetic field due to the time rate of change of electric field ani ve thung tani displacement current kan zir to a conduction current om ti po kan threto a ti chuan displacement current chuan magnetic field alo siam ve a engwang he kan ti chuan due to rate of change of electric field lo chereng awang capacitor plate in kara electric field chereng awang khan magnetic field lo in siam ve tani chu anom dun ani chu electric field chereng in magnetic field chereng lo siam ve ta ani. Thus in the space between the plates of the capacitor both the electric and magnetic field exists, which is the origin and production of electromagnetic wave. Chu lo chona choni tani capacitor plate panin kara electric field chereng mo displacement current ina siam electric field chereng ina magnetic field lo siam khan an pani khan bo ruaka an lo phone chuak ta hi mai tiang waves angin alo in produce tani chu. The true fields combination to constitute electromagnetic wave. Chu electromagnetic wave kan ti chu ni tapai mai ani chu an frequency rang a produce a material zirte man ro zirte energy zirte wavelength rang frequency rang lo pe chuak ta chuang chuan electromagnetic wave chi rang lo om thei ta ni chu TV man turte radio man turte mobile phone man turte mo internet a ka tiang man turte TV po channel rang frequency chi rang remote control te pon pe chuak ka tiang kha wave rang khalo om ta ni chu ti chuan hei arsa kan hem hin microwave oven hin microwave pa chu ka chung te po chu electromagnetic wave chi khat tho ani ta ni chu mo. So in space in a direction perpendicular to the direction of both the fields with the speed of light eng kluka chakin boro ka an phone chuak ani chu an kalta chakle mai chu wangchon ni mobile phone po kan biak rol hin eng kluka chakin kala delhi te po kan su biakin an thre thei ngal tu ti lo se sound chu second khata meter zathum vel chu akal theya amwang don lutuk idam mo kan in ti chuan dar ka renge mo zata an lo khedon chau idam mo ti kha ma se eng kluka chakin kala wangin mobile phone te po kan in biakin kan thre thei ngal zung ta ni chu alo tang kai khom mai. And number 2, electromagnetic waves are also produced due to accelerated charges. Charge can be in motion. Conduction current a chan wire a chuan electron kha an luang ite mai tiang an kala an in pass zela current kha chu chuan conduction current a siam ta ni chu masen accelerate mi alo ni chu there more accelerate low. However, if we accelerate the charge can accelerate ni chuan. For example, electron, if we accelerate, then it will produce changing electric and magnetic fields. Alo siam ta chuan electromagnetic waves alo pe chuak thei ta thoni chu mo chu wang chuan accelerated charging siam ta electromagnetic waves are also produced due to accelerated charges kan tia tin charge hi accelerate kan ti chuan thil pan hiom thei. Number 1 is it will change its speed or velocity per time. Accelerate velocity ka second katamo second niemo minute ka a change rang chuan ain accelerate kan tia I chuan antian motor te po kan accelerate kan ti chuan kan kal chak thut ta a velocity can change mo a speed can change ta accelerate kan tia chu tiang che tho chuan charge accelerate thei ta chu ba ka chuan a velocity change me alone. And another thing is without changing its velocity but it changes direction in lai point direction a change hian accelerate tho kan ti antirnan ni khovel in hela khovel in kwal renga ain accelerate char ni chu a direction a change reng ma se speed a velocity to change me lo ma sela change me lo chu ni lo wa a nei line a velocity chaka a lat line a velocity among ti chu kan thra thona chungin ma se velocity change me lo nga lo ngai taila kwalin tian amai ro chu a direction a change chuan when something changes direction continuously that means it is accelerate kan ti tani chu bokina ti chuan charge when it moves in circular motion without changing its velocity then it will produce electromagnetic waves mo lo pe chole thei tani chu chuan how do electromagnetic propagates in space ka poi mo tani hey ale mami yang hian boru ka phone tan chu ni ya e vector ki electric field kha chunglam zong in perpendicular to the ground ground nen hin perpendicularly polarized kan tia lane na in perpendicular in a phone ta and tirnan chu tia ni chon lane na electric field perpendicular in phone chuan then magnetic field chu lane and horizontal in a phone chok don ani achan chu because electric field and magnetic field always perpendicular to each other tinkin borok a rual chain and kal chok ta ni chumo john so the propagation of electromagnetic field is in the direction of vector E cross B kan titani E stands for electric field vector and B stands for magnetic field vector. Since the electric and magnetic field are perpendicular to each other into the direction of wave propagation, the electromagnetic waves are transverse in nature. Just transverse kan lo tita. Then the speed of as said earlier, the speed of electromagnetic waves in space is given by C equal to 1 by the square root of mu naught E naught epsilon naught t kan tani to. Ya kan huanga. Mo kaka James Clerk Maxwell and say talk ta ka derive chua nuwa formula atopami ka C equal to 1 by square root of mu naught E naught epsilon naught ania kaka mu naught to permeability of free space and epsilon naught to permittivity of free space kaka na soi fianga a value po kha numai kan tarlan khan ya hey poi mo kami value pan ni kan handa a kan cho chwa chuan it is about 2 into 10 to the power 8 meter per second eng tluka chakina local ania chumi mu chu electromagnetic waves hi eng tluka chakin phone akal chua mase anan zirchian zel khan electromagnetic waves electromagnetic eng chi rang zong te ascent te apol te le microwaves te x-ray kan ti te gamma ray zong hi engdang ni loin electromagnetic wave chi khat vek zo khalom le ti kan lo thre chuaka chu wang chan eng tluk chak vekin an kala electromagnetic waves vek an lo ni zo khani chu mo heng zong hi lekin electromagnetic spectrum kan la ziram so it propagates in space transverse as transverse wave which is electric field and magnetic field are perpendicular to each other and also to the direction of propagation ti khan an phone chuaka ti khan achung le nuai asir le ti khan an phone dun ta chu ti rol ma zong an pan sia mo zuang ta la ma zong pan ta la I chu sot thok la malam pan si la I malam pan na le I zuan na chu ain perpendicular chi ani chu chunglam zong in zuanga ma se malam pan sia chu tiang che chu electromagnetic wave chu an phone na ma se malam an pan chu wang thil pathum in perpendicular ni chu he alema hin in mu chuan thil pathum in perpendicular asira hin in mu chuan B E V in munga direction V kin munga he sira right hand side akin munga x y z axis akin B ki magnetic field ki is y axis ni ta sela E2 then it will be z axis then V direction will be velocity will be in the propagation will be in x axis ni ta ni chun engzong ki magnetic field ni ta se ascend wave sen hi electric field lo ni ta ti hina rolling boroka kal chuka he changing electric field and magnetic field in a siam ani wani jon boro kan lo phone chokta so it travels with the speed of light eng lu ka chakin a local phone chokni electromagnetic wave mo tu chuni tani chu ti chuan a red light kan ti te white light kan ti te eng light po ni ta sela microwaves ani mo radio waves ani mo changing electric and magnetic field boro ka zam vel tham vel phone vel ani berani chu mo and next is so this is how electromagnetic waves propagate in space. So you can see the blue is represent the magnetic field and the orange color represent the electric field and they are directed towards x-axis. Okay, E field is y-axis, magnetic field z axis. They are perpendicular to each other and also perpendicular to the wave propagation. Okay, so this is speed of electromagnetic waves. its formula is C equal to 1 by square root of mu naught epsilon naught. Its value is equal to 3 into 10 to the power 8 meter per second. Now let's talk about permittivity and permeability. You can see that in the square root there is mu naught epsilon naught. This is mu naught stand for permeability and E is not stand for permeability of free space. Not represent, zero represent the free space. Free space. Eng mom lo na electric field magnetic field pona ti boy lo na van thing ring. Akilo tang se chunga chon eng hi akal chak zong ni amaro chu eng te hi water at medium at chon akal chak zong hi amuang ta ani chu wang chuan akal chak zong hi in medium le is free space kan compare chuan I eng po hi material azir khan aluminium akal tlang ni mo glass akal tlang ni mo khalo danglam thina chu a material ina a properties nei ne refractive index kan titani chu mo kha refractive index ania tin chu ba ka chuan I electric field mo electric field I akal tlang electric field hi boru ka akal tlang hian electric constant an nei theu maya chu electric constant chu material azir khan adang lam theu ta ne chu mo materials entir nan charge pani electric field in car hi boru ka da taila mase chu charge vek chu distance in angin tuya da taila tui chunga chuan and force the force between the two charges will be very much difference is za somriat line lo tla hiamani chuin hip ton na chu thithiam an electric field khalo chak talo sat jok tina nia I tuya kan zuda khan thithiam chu tiang glass apo alet nga let so alang tanga som velin alo tla hiam thina ni paraffina chuna let ni velin rubber let sari velin electric field khalo chak lo sat ta ni chu chumi om je chu engkim mai khan material khan electric constant an nei ta vek ta ni chu E not permittivity kan ti khan ta ni permittivity it represents the capability of a vacuum free space to permit electric fields. Or we can say it is the property of the material which measures the opposition it generates by the material in the formation of electric field. Electric field local na turatan eng tiang nge boro kina mo material in alodan electric field ka. Anita keni po tui kan leu chuan min lo dang de ta boro ka leu ngot ai jan boro ka tlan la olsam tuya tlan la harsa khatiang khan tu in force lo nei khatiang che khan material rang hen electric field an kal tlang don hen I lo dan theina opposition khan lo generate ve thine the property of material which measures the opposition electric field chu electric constant kan ti chuni epsilon naught permittivity kan ti chuni ta its value is 8.854 into 10 to the minus 12 coulomb square per newton per meter square material azirina danglam vek dona hemi hi chu free space kan ti hi chu van thingrang free space engma material engeniang molecules particles omlona magnetic field electric field ti boilona mun nang ni ta se chu tiang chulo om theita se ma electric field magnetic field eng field mo hi alo om zel na om lo anga ni chu tiang nga chon eng tluka eng hi akal chak zong 3 to 10 to the power 8 meter per second ania amai ro chu tuya te glass ate material paraffin ate rubber ate chuna danglam don ani chon mu naught also is a permeability ti ve thung ta mu naught mo permeability chu a magnetic constant anti ve thung ta ni chu ni chen mi electric field kal tlang tur adang thinang khan permeability ve thung chu magnetic field eng tiang all sumin nge akal tlang tir thil rang hian material hian magnetic field hi alo accept thei permeability measures the ability of the material to allow the magnetic lines of force to pass through it magnetic field hian lines of force ania kha local tlang tir phalna sa apiang kha I unpermeability sang ti na ni don tan kal tlang tha thei don ti na ni ve thung ta chu magnetic constant ania mu naught permeability of free space tichon material zero zel kanan permeability kha danglam theu dona chu mu ani ringota masa mu naught kan ti chon free space atan big tina ni chu engmam lo na khan akal tlang thaber don tina nia masa I glass te water te aluminium te khati han kal tlang thadon lawan material zir khan a value of permeability will be different tero allow different so mu is also equal to B by H where B stands for magnetic induction okay magnetic and H magnetic induction ania and H to magnetic field intensity khan ya and its value is 1.257 into 10 to the power minus 6 Tesla meter per ampere ani tani chu magnetic constant la electric constant chu poimo electric constant epsilon naught permittivity of free space kan ti chu van thengreng eng ma omlo na eng hi mo electric field akal tlang I alo dan na I may think opposition offer material rang in opposition offer permittivity antia so permeability ve thung chu electric field ni lovin magnetic field ve thung magnetic field hi eng tiang nge local tlang that thei again the to measure the ability of the material to allow ani chumo to oppose ni lovin to allow the magnetic lines of force to pass through it and kaltlang thei zong te khong ni ta ni chu mo khana danglam theu don ni chu material is hey mi big eroi chu free space ai ro chuan it will not change the value is not changed in free space a chuna danglam lo ni mo hey we can use it's a universal constant however it will change according to the properties of the material we use. And next, properties of electromagnetic waves in space. There are 12 properties in our textbook, so we will learn according to the textbook. Number one is electromagnetic waves propagate in the form of varying electric and magnetic fields such that the two fields are perpendicular to each other and also to the direction of propagation of the waves. In other words, electromagnetic waves are transverse in nature. Hey, we talked about this already before. That's why I'm not going to say more. And the next is electromagnetic waves are produced by accelerated charge. Also this point number 2 also I have explained already, so I'm not going to elaborate much. And the third one is point number 3, properties of electromagnetic waves. Number 3, electromagnetic waves do not require any material medium for their propagations. Hey, electromagnetic wave rang hian e kaltlang nan thilan mamolo sound te chu kaltlang nan material an mamoni era o manga thing o manga electromagnetic wave chu hey light waves te pon ve ka vana khian van theng renga eng mamlo na hina kaltlang theini chu. And number 4 is in free space electromagnetic waves travel with the velocity of light nichina kan sei so with the speed of light eng kluko chakina kal ma se aleling zong che in eng zong te microwaves te gamma heng zong hi eng dang nilovin electromagnetic wave zo kaloni ti kha kan thredona nia. And the fifth one, the refractive index of the material medium is given by nichina so to refractive index eng hi free space kal le tu ya kal hian achak zong inang don taloni. So it depends upon the velocity of light depends upon the material of the medium. Chu eng tiang chin nge in depend ka it depends upon the property of the material anitani. Ai nang don lo tuite glass te mo khatiang I paraffin te wax te oil te mo badam tel sunflower tel khang zong zong ang don lo ba engan kal chak zong kami kha an mani properties nei dang thewa kha c by v kha kami kha c is the velocity of light in space and v is the speed of light in a medium anitani, which will equal to something which is called n or mu and da thina maro chu mu kan da in helai hen mu hi permeability tan kan mana wangin aboi thaka optics zirna chuan mu hi refractive index ti in and da thina ni chu mo refractive index mu ta hi chun n kan ti ni chu n ti chuan in n to refractive index anitani ti chuan in parugna chun the electromagnetic waves obey the principle of superposition hi waves here in suthaya energy can distribute and redistribute in samsum le theita na ngai na kal le thaya antinan shui ta chuti na kan vai hian hui pa ni ron kala anin suwa ti chuan in and distribute le thina ni a hai chu superposition chungchang hai chu chiang zokin nang mani point lo chiar down ni kan so effect man long. Number 7, the electric vector is responsible for optical effects due to electromagnetic waves chu chintania chu wang chuan for this reason electric vector is called light vector anti hey mi thil te kan share kan hu theina siam tu light wave zinga mi hi magnetic field vector ni lovin electric field vector zo khian min hu thei tir ni chu electric field vector or magnetic field vector anam dun ve ma se electric field vector is responsible for optical effects no thil min hu thei tir tu khan ta ni chu. And number 8 is the variation in the amplitude of electric and magnetic fields in the electromagnetic waves always takes place at the same time and at the same point in space and anan phone chua khan a rual chin an kal duna an amplitude point ang chia time in ang zela khan chu wang cha phone sang ani chuan electric field phone sang lai le magnetic field phone sang lai chu in zone zeli ti mai te yang chu wang chuan e naught by b naught is equal to the speed of light alone tani chu. Thus the ratio of the amplitude of electric and magnetic field always constant zel ani chu ain an zel wang constant ani mayang toite te in. Number 9 is the energy in electromagnetic waves divided equally between the electric and magnetic field vectors ani energy nei electromagnetic waves in the low for near tongue in angle local point energy nei mo chu energy to u anti thina. So ue represents stands for electric energy and density, ub stands for magnetic energy density in tani John, which is always equal. ue is always equal to ub. Also we can represent half epsilon naught e square equal to half b square by mu naught is zong pon zia thei tani kha equation point mo takania you want energy ne ha the boru ka hian rong kal tel vezel ani ti kha theta phot maya moila. Number 10 a chuan so the energy kha antin gen local thei mo which direction. So this pointing vector tells about the direction of electric field. So what is pointing vector? A pointing vector is a quantity describing the magnitude and direction of the flow of energy in electromagnetic waves. Khoi zong energy ka electromagnetic waves energy ka flow is safe to pointing vector ani. The energy transported by electromagnetic waves per second per unit area is represented by a vector called quantity s called pointing vector. S equal to e cross h 1 by mu naught e cross b tipon azia thei tani kha equation ania objective type ba po chuak thut thei ni. Number 11 a chuan electromagnetic waves in momentum ani ve tho bokani chu. The momentum transported by electromagnetic wave is given by p equal to u by c. Capital U chu energy of an electromagnetic waves ania c stands for is the speed of light. Okay, speed of light kind of momentum ani ni chu. chuan number 12 ba chuan momentum ba ka intensity kan te maya hey intensity of electromagnetic waves and tirnan a in mombati pa ni te po chitai la energy nang ve ve po ni se kan en na hlat zong poi nang po ni se mo a len zong poi nang po ni se a eng zok te ve thei ta ni chu chu bang cha a eng zok kha luminous intensity sang zok kan te thenga bulb po wat som ni panga ve ve om ta sela mo bulb what a energy a ral chin nang ve ve mo mai ro chu an pek chu kha bulb kha a eng zok om thei ta ni mo wat som ni panga ro led te chu tungsten filament ai chon eng zok de ai ralinang ama intensity ma sang zok ani chu wang chu intensity luminous intensity sang apiang kha a eng dom zok khatiang do khan electromagnetic waves also have intensity of electromagnetic intensity which is energy crossing per second second khachung energy cross tama piang khan intensity sang tina allow ni don tani so it is represented as I lo ni tani chu so you can see the equations half E naught B naught divided by mu naught is equal to half B naught square by mu naught C equal to half epsilon naught E naught square C yang zong po khan represent ni ikhan so we learn about properties of electromagnetic waves. There's 12 properties of electromagnetic waves and tani when I kan sir kan ti chuan we talk about propagation of electromagnetic waves day, production of electromagnetic waves day, definition of electromagnetic waves day, and the 12 properties of electromagnetic waves. Boro ka phone dante properties te kan lo zero ta ani ka kha in lo chir non le don ni textbook a. And also you have to think about these questions. You have to answer. It may come in the exam. What are electromagnetic waves? How do they produce? How do they propagate in space? Explain with diagram. Write properties of electromagnetic waves. Exam na write any two properties or write any four properties of electromagnetic waves ati mai thai. And also objective type can come from properties of electromagnetic waves. Electromagnetic waves rang kan properties kha alo kal thai bok ani. Ole kha voin kan zir chu ani in lock wing ai pok bai sia chatakin lo chi zir chun jamula assignment chu om lo wanga mai ro chu but you have to read again and try to answer the following these questions. Okay, thank you.